Start your picture.
तो स्क्रीन शेयर कर दूँ
Yeah. Just.
Okay, so screen is visible right now.
Yes, yes.
Okay, so the topic for our project was house price prediction with using advanced regression techniques. Okay, so basically these are the team members: me, myself, Divyanshu, Shavya, Prem, Shioshi, and Benedict. Okay, so let's come to the business problem. So the business problem was like it revolves around enhancing user experience and enhancing customer engagement by providing them personalized recommendation for house price prediction. And the model we used was like regression techniques that were like different types of regression techniques. So the next part, what the objective of our project is, first it was like data collection and integration to gather the data sets which was like easily available on Kaggle. So we just obtained it, we worked on it. Then we built like we trained model using the training and testing data, the regression techniques. Apart from that, the output we wanted was real-time prediction so that the user can get real-time predictions of the house price, like house prices, which he wants according to the input data fields he gives. And for the most important thing was how well the model performs and the accuracy of the model. So apart from that, these are the few basic regression techniques like we used in it: linear regression, random forest, gradient boosting, ridge regression, and neural networks like it's at the end. So these are the few solution approaches that we have included in our models. Apart from that, the scope recommendation was like divided into two part: how the user feels, like the user's point of view, and what the models like the model has to give. So basically, two parts of the project, which it highlights. And the next thing, data set. As I said earlier, it was obtained from Kaggle, and first it was like the data cleaning,
Yeah.
how we did.
Divan, sorry for interrupt. I have one question for you, Divan. This is
Sure.
advanced regression, and you are doing some recommendation. Can you explain what is actually the statement?
Uh, statement in terms of like we have used regression techniques just like to validate or train the model, and when the model has been trained, then when the user gives the input, like when the flask has like on the flask app, so that whenever he gives the input accordingly, how many rooms he wants in his house, how many bathrooms it must contain, how many cars he have, so that accordingly the garage must be there, how
Can
many
you show me?
how much.
Can you show me the result, please? That application.
Yes, ma'am, sure. We can just skip this training and testing, which is like data visualization.
Mhm.
Both Power BI report is also there for this
Okay.
deployment. This part is for Amazon AWS using EC2 and
Okay.
buckets. Okay, and for this one is for this Flask app, which I will show you just right now.
Okay.
So this is a conclusion part. Like the lowest error which was there, it was in a linear regression. That also the stacked one, which it's nothing. It's just a stacked linear regression which improves the modularity and this your um, output. Basically, we'll say the accuracy of the model. It just improves it. So that's why stacked regression model has been the most easy and the most accurate part of it. So let's move on to it. The Flask model. So, okay, so it's been running. So this is the interface for it using stable and CSS, just a basic one, not so flashy. But yeah, so here are like what the rooms you want, like 5 rooms. I need 5 rooms in my house. How many bathrooms you need? I need 3 bathrooms. Land size. So land size basically 1,000 square feet or something like that. And latitude and longitude just for like the area where you want your house to be. Like I can give a random for the latitude and longitude 144 something. Distance is basically how much area the total it covers. I can write just 50 or something. Car, how many number of cars you have? If I have 2 cars, building area. Like this is the land size. Like 1,000 square feet is my land size. In that, how much area your building is occupying, like the house is occupying. From 1,000, I can tell like 800 square feet is for my house. The rest 200 square feet is for gardening or something, anything. Year built, like the house, when you want the house to be like, we are buying, right? So if it is pre-made house, like all, of course, it is it's already built in the past. So like accordingly, in which year the house was built, you want to buy. So like if I want a house which was built in 2010, property count is basically the locality, like near the property, how many more houses are there. So like I can tell minimum like 10 houses should be there near my property. Like just when I submit it, it will show you like the predicted house price is this much dollars. Accordingly, the land size, this one, it's the same input with the predicted like the predicted house price, what it like the conclusion, what it the user will spend, how much money he will spend on that property, and this is the total value for it.
Yeah, this is the good one, guys. Too good one. Yeah. Show me the AWS what you did.
AWS, like I removed on that day only because like everyone was doing on Flask, so I just did on like AWS. I just uploaded it on Bucket, and I just ran through it. And after like running through, then I just removed it and I did again it on Flask.
Okay. But you showed something in PPT about
Ah,
some.
yes, ma'am. Yeah, this one was like it was when the time when I like uploaded it on, like I added the files in the bucket, then like deployed it. Then after like when other teams were doing on Flask, so like some of my friends said, like the early group one said, the Flask is like the Flask running is mandatory or something. So I just removed, like I dropped this AWS one and I did it on Flask again. So that was, I
Okay,
modified it.
can you go to the Power BI one?
Yes, ma'am. Sure, I can show you the Power BI one. So this was the Power BI report accordingly, like how much sales it has been done. Like in the last like in the mid evaluation, I showed you this, but again, like just to be clear, in 2009, how much property was been like sold. In 2006, how much properties were sold. So like just a live interface of how it works.
Okay.
So anything else, ma'am? Like any queries?
Okay. Okay. So I find your project is very effective. You people also explained it well, so this is quite fine. Now is the time of question answer a mock interview. Fine. So
Sure.
okay. Can you people explain about feature engineering? What type of techniques are there?
Feature engineering. Feature engineering, like from the model, like
Yeah,
from the
like
machine learning.
if we are having high dimensions of data, more dimension data, then
Okay. So feature engineering, or like the dimension, I will say like dimension reduction. Basically, feature engineering will be like extracting the key or distinct features from like any of the datas or something, just to make it small or like less compact. So like the uh, even after dimensionally reducing it, it does not affects the output of the data. And so that I will say like it's what feature engineering is. Different techniques might be like reducing the dimension reduction. Of course, it's one of the technique where we just like pick the distinct parts of the data, or like we ignore the duplicate or the repetitive part of the data just to make it smaller and like less more readable, to be honest. and so that it gives us an accurate like result. Because at the end, no, like if we go like using the CNN and every model, like it won't matter, because at the end of the max pooling layer and every layer, it will be again like the output will again will be maximized only. We maximize it like before the max pooling layer. So just the training data, training data, we just reduce it and we extract the distinct features from it. So that's what feature engineering I will say is.
Okay. Sure. So, in which model you are getting highest accuracy? The finalized model.
The Okay, finalized model which we got was stacked regression model. Stacked regression model, as I said, is just as extended version of linear regression model, where multiple linear regression model is used. Like as I showed in my Power BI report also, like for everything, like we have multiple inputs to be given by the user, like bathrooms, number of bathrooms, number of rooms. So every each and individual factor affects the price of the property and like what the user will spend to buy a house. So for every individual this data set, so every individual entity, we have used like different this plotting, like we have shown it through different plotting and everything. So that's why for every each and individual between like x and y axis, we have used one regression model, then linear regression, then second linear regression. So basically stacking and compiling it up will be a stacked regression model. So it just like it's better than regression model, like linear regression model, because the output predictability and the accuracy enhances in the stacked regression model.
Okay. The next question is how a null hypothesis is different from Z-score.
Okay, how null hypothesis is
Different from Z-score. First, you explain null hypothesis, then you can explain Z-score. Or hypothesis testing. Are you aware of hypothesis testing?
hypothesis testing, like two types of here, like we have studied like chi-square and z-square, like z-square and chi-square, I guess. Z hypothesis and chi-square, two types of values just to predict. Like in the regression model also, in the if I will show you the thing, in the regression model also, the end product what like decides that which model is superior than the others, because we have used multiple regression model. So the factor which decides that which model is superior than other is the RMSE values, the root mean squared error value. So whichever model has the least RMSE value is more superior than the other. So that's why it, like at the end it decides that stack regression model is the most prominent one, and the uh, uh, this one random forest is the least prominent, or the least lowest accurate one. So that's like the RMSE value decides it, and accordingly the chi-square and like this one z-square value is of course the factor which like it has been considered it. So if we say like
Are you
what is
aware of
chi-square,
Z-score? Okay. Do you
yes,
know
from z
what is IQR?
IQR, like if you can tell the full form, I can I can remind it into
Because
this.
you need to tell Divyans. Okay. Interquartile range. IQR.
Okay, interquartile range. Okay, okay. So interquartile range is basically like a set parameter, like when we use like when we start from the training data and testing data, and as we build the model, there is a range. Like we cannot like train the entire this machine learning model in one go. We have to use ranges. Like first, it will train the 25 data sets, then 25 to 50, then 50 to 100, then just to make sure that it overcomes this underfitting and overfitting. Because if we train in one go, then it might be a case that overfitting might occur, because the model might be too true to be evaluated. It might take everything like in an accurate manner. And underfitting is basically if we don't provide enough data sets and everything, but it won't be the case in our model, because almost 1650 data sets have like in rows and columns including it's 1650. So data sets are more than enough. Apart from that, and overfitting is not there, because like we have used this ranges. Like first it will train the first 25 model, like first 25 data sets, then the next 50, then the next 75, like this. So for that it has been used. If you're like looking for a definition for interquartile, then like I
No
cannot tell it
definition.
entirely.
I don't need definition. I need the explanation. Okay. Fine. No worries. Okay. Are you aware of decision tree?
Yes, ma'am.
Can you explain how decision tree is working and what are the main disadvantages of decision tree?
Okay, so when decision tree basically works on the factor what like how the user it entirely works on the user's perspective, like whatever the user or the model has to predict. If we can bifurcate it in simple graphs and trees methods, we can see like every node had two subnodes, like two subnodes, and if a user selects yes, like just as example case, if a user selects yes for a thing, and if a user selects no for a thing, so if it select yes, then the decision tree will only see the yes part and it will ignore that all no part, because it doesn't has any value for it, because the initial condition was like if the user says yes, then proceed. And if the user has already said yes, then it will just check the yes and the all subtree parts, like subnodes part. And if the like if the machine wants, like if the user says no, then proceed, then it will check the no part and it will ignore the yes part. So that's the type of like decision tree it will go on. Depends on the depth, how much depth the decision tree has. So accordingly, the complexity of the model depends on it.
Okay. So, yeah. So what is the main disadvantages of decision tree algorithm?
Okay, so my decision tree is that the main disadvantage which I know is like it may overlook some data, some data which because it doesn't checks the no part, right? It completely ignores the negative impact of the uh, input. So there might be something like which on evaluating further might change the outcome of the model. So it ignores that thing, and it just goes with the positive value or the value which needs, like which the user gives. So it just trains the model accordingly. So it may overlook some data or some things which might be necessary for the model to be trained, just to avoid some kind of errors, or like to provide more accuracy to the models. So that's the thing what decision tree lacks.
Okay, Divyansh, have you heard about something, one term overfitting?
Okay, yeah, sure.
What is overfitting, dear?
Overfitting is basically, ma'am, when the model is too good to be true. To be in a layman's language, it's if the model is too accurate, like in the first go only. Because machine learning models, it cannot be like we cannot think it to be an accurate model just on a first go. So if we give a set of data sets, okay, and the machine learning model predicts it too accurate, like it's too accurate in the first go only. So it might be a case that the like it has been reading the data, or it has been reading the data too well, so that the model has been developed too well. So just to be case, like because if only if a data sets contain only positive values, just an example, and it doesn't contain any negative values, so if you'll give a positive value, then of course the result of the outcome of the model will be positive, because it hasn't been trained on any negative values. So overfitting is like that only. It's too good to be a true model. Like no matter how much data sets you have given, you have used, it might be the case might be like because this the data sets might be too vulnerable, like no such fluctuations in the graph. In the graphical term, if we say that it plots every single data sets in the graphical term, overfitting plots every single data sets, and accordingly it predicts the output of the model. So
Okay,
that's what
okay,
overfitting
Divyansh.
is.
Yeah. So in decision tree, you are facing overfitting problem. How you can prevent that?
Okay, ma'am, overfitting can be this one, I think so by using normalization. I don't remember correctly, but I think so by using normalization we can overcome it.
Okay, normalization techniques. Can you explain what are the techniques comes in?
The one which comes to my mind is this batch normalization, using like using the mean and everything, just to predict just to train the model to be a little bit fluctuated or little bit flexible, just not to be like too constant or too tensed, so that it gives the value according like too true. So accordingly, I think so batch normalization is the only thing which I remember right now. I cannot remember of anything else.
Okay. Okay, dear, no issue. Can you share your screen? I need to share some coding questions.
Sure.
Let me see. Google Colab, Jupyter, anything, fine.
PyCharm will be fine right now.
Yeah, anything fine.
Oh, sure.
Okay.
So screen.
So yeah, write a program to find out a string is palindrome or not.
String is palindrome or not?
Ah.
Oh. My I just use Python for this projects works. Like I have knowledge, but yeah, my main language is Java.
Or Java, you can write it. You can write in C, C++, Java, anything fine. I wanted to see the result, dear. Anything fine. And what about our teammates, Paul, Shurya, Prakash, Shri? What about you guys?
Yes, ma'am.
Okay, help him to write a check a string that is palindrome or not. Any language, it's fine. Java, C, C++, Python.
This, let's see. Okay, so you have to check the string is palindrome or not. Basically, loop which will run from index 0 to like the string s dot length, uh, which is bot. And let's see, we have to check the if the starting in the okay. So there are two ways we can do. Like we can compare like if s dot caret I. Okay, if s dot caret I, this means like just I'm telling you the logic, one logic which like just a brute force method that a word a string to be palindrome is basically if the um,
It
starting like the first
reverse means it will come the same only. Bob,
the same thing.
madam, madam.
So the thing which this thing which I'm like which I'm thinking is like if the first index like the index the first position is equal to the index of the last position. Like if the b is like if the b is present and at the end also like if it will compare the first index and the last index simultaneously, and it will just I plus plus it will go on. So we can do like this. The first thing which comes in my mind is this: like if s dot char at I is equal to s dot char at let me do this. Int n is equal to s dot length. We can tell that I is less than n. Okay, so if s dot char at I okay, so if it is equal to, it will just, I can take a integer count plus plus and okay, so we'll just do count plus plus bob. For the last one should be remaining. So basically okay. So count here, if we count let's see. Okay, out of range.
Divyanshu, I'm so sorry to interrupt, but I think it will be easy for you if you just reverse the string and then compare both of it.
The first thing I thought was like this, but yeah, I can do that also. Like I can run two loops, one for forward and one for backward. Like
Uh,
for
You already have the forward string, so that's not necessary.
I is equal to s dot length I is greater than is equal to 1 and I minus minus. Okay, so if for comparing part
Okay. Depends, it's fine. No worries. I will give you another question. Okay. Just find the factorial of a number using any programming language. Find the factorial of a number.
I guess this will be enough. Okay, 0. F is equal to 1, I is less than is equal to 1. Let's see. It's fine. Is equal to done.
Okay, nice one, dear. Okay. Okay. Yeah, fine. So, Divyansh, I am quite appreciated with your work. You are a good individual contributor. Coming to my feedback, okay. You are a good individual contributor. Coming to your teamwork, yes, the project is you people tried good. Uh, but somewhere what I feel, coding wise, it's fine. You people need to little more focus on the machine learning part. Okay. So other things, I loved it, guys. It was really good. I spent 1 month time with you people for the training and all. So this is quite, I'm sharing my experience with you people. So how you can prepare for your campus placements, like this type of, you can show this project, you can upload in GitHub or LinkedIn or to a data scientist, different platform. You can show in your CV that will make good effect. Okay. So this type of question they will ask in interview. So ready to prepare for it. Fine.
Sure. Thank